Okay, today we're going to have an introduction to limits of accuracy. Finding the limits of accuracy is a little bit like the opposite of rounding. We're going to start with a number that's been rounded to the nearest 10 and it turns out to be 60. So we've got to try and figure out what that number could have been. Second example, we're rounding a number to the nearest whole number and it arrives at 7, and the final number's been rounded to the nearest 100 and ends up being 400. So we're looking for the limits of accuracy. That's the maximum and minimum value that the number could be, what we often call the upper and lower bounds. And as this introduction, I think it's a really good idea to start with a scale. So if this number has been rounded to the nearest 10 and it's 60, the previous number it could have been rounded to is 50, 10 less. And the next one up would be 70, 10 more. So whatever our number is, it's fair to say that it was nearer to 60 than it was to 50 or 70. So if I find out where the halfway point is, so halfway between 50 and 60 is 55, halfway between 60 and 70 is 65, we can say for certain that our number must be in this range here. So it must have been greater than or equal to 55 to round to 60, or less than 65. Because as we know with the rules of rounding, even though 65 is halfway, 65 itself would round up to 70. It's mathematically correct to call this the lower bound and this the upper bound, but we can use inequality notation to help us. So if I say my number was x, I know that it's greater than or equal to 55, but less than 65. And I don't put the equals part on here, so that inequality is now true, and that's a really nice way of doing it. With the second example, the number is rounded to 7 to the nearest whole number. So the next whole number down is 6, the next whole number up is 8. Once again, if I think of this idea as the scale, the halfway points will be 6.5 and 7.5. So my number must have been somewhere in this range here. So if I call my number x, it must have been greater than or equal to 6.5 and less than 7.5, but not equal to. An important point here is that this has been rounded to the nearest whole number. So the gap, the difference between my upper and lower bound is 1. With this one, it's been rounded to the nearest 10. The difference between my upper and lower bound is 10. So that's something to look out for. So with the final one, it's been rounded to the nearest 100 and it's ended up at 400. So the previous two numbers it could have, so the previous number it could round to is 300. The next one is 500. Once again, we have this idea of a scale. 350 would be halfway between. 450 would be halfway between. So my number must have be lying in this range here. So if I use the inequality notation again, x must be greater than or equal to 350. Remember, this is the number that's been rounded, but it must be less than 450 in order to round to 400.